everyone, welcome to our channel. In this video, we will solve more questions of TIFR JGEEBILS 2019. If you have not watched the previous videos of solved PYQs of TIFR 2019, then you can go to the I button and watch them now. Now, before going to today's questions, here is a reminder for you. If you are doing your B.Sc and you need to test your preparation, then on Unacademy platform, you can do that. You can take the free MCQ test series on 25th March from 2 p.m. There you have to solve 50 questions in 90 minutes time. So if you have not installed the Unacademy app yet, then do it now. Here you can see this year's IT Jam toppers who were beneficial from Unacademy's Plus classes. Biotechnology, physics, chemistry, maths, all are beneficial. For all the subjects, they are beneficial. Okay, and you can also take the Plus class subscription using my code for 10% discount. The code is PHYSJAM-570. PHYSJAM-570 is the code for 10% discount in Plus class subscription. Okay, so let's go to our question today. This question came in TIFR 2019 and this is from vector. So here the question is, a ray of light is incident on a mirror and the light travels in the direction x cap plus root 3 y cap and after reflection travels in the direction x cap. What is the angle of incidence with respect to the normal to the mirror? Option A 30 degree, option B 60 degrees, option C 90 degrees, option D 120 degrees. And you can see that 60 degree, that is option B, is the correct answer given in the TIFR website. Okay, so let's analyze this question and see that if we get the same answer or not. Okay. Now this question is a little bit complicated. I will not say complicated, but this question is a little bit tricky so that you can get the wrong answer. Okay, so listen very carefully. Okay, first of all, we have the incident vector as x cap plus root 3 I cap. So let us take it as a vector. Okay, so a vector equal x cap plus root 3 y cap. Okay, x cap plus root 3 y cap, and the reflection vector is x cap. Okay, so b vector is equal to x cap given. Now watch very carefully. So if we plot them, okay, so if okay, so this is the x-axis, this is the y-axis, right? And our vector is x cap plus root 3 y cap, right? That means 1 x cap plus root 3 y cap, right? So along x-axis unit vector is x cap and along y-axis unit vector is y cap. I hope you could understand that clearly. So we are going 1 times along x direction and root 3 times, suppose this, along y direction. Okay, so this is our required point, right? This is the point, and from origin this will be the vector A, right? And vector B is x cap, that is this. So this is the B vector. That means the incidence vector is this and the reflection vector is this, like this. Is it possible? Can it be possible? No, right? Because if here is a mirror, okay, something like this, okay, so how can it be, be the reflection vector like this, right? So the reflection vector would be like this, right? That is, this B vector will be minus x cap. This B vector will be minus x cap. This is something given in the question, which is a little bit confusing for you. It can be a confusion for you. It can create a confusion for you, but you have to analyze this, the question, and have to understand this clearly. Okay, so we have A vector equal x cap plus root 3 y cap and B vector equal minus x cap. Okay, and you were asked that what is the angle of incidence with respect to the normal to the mirror. So if we draw this again, so this is our mirror, this is the incident ray, and this is the reflected ray. Okay, and this is the normal to the point of incidence. Okay, so this is the angle of incidence, theta, suppose, and I hope you know that from the laws of reflection, the angle of incidence is equal to the angle of reflection, right? That is, if this angle is theta, then this angle would also be theta. So the angle between A vector and B vector would be 2 theta. Okay, right? So let me write here, angle between A vector and B vector equal 2 theta. Okay, so we have the angle between A vector and B vector as 2 theta. So we can now take the dot product of A and B vector. Okay, that is A vector dot B vector. Why? Because we know the formula for dot product is A vector dot B vector equal mod A vector into mod B vector into cos the angle between A vector and B vector, that is, here it is 2 theta. So cos of 2 theta. Okay. Now what is A vector and what is a mod A vector and what is mod B vector? Mod A vector is the magnitude of A vector and mod B vector is magnitude of B vector, right? So how to calculate it? So mod A vector is equal root over the sum of the square of the coefficients of x cap and y cap. Okay, here it is 1 and root 3, right? So 1 square plus root 3 square. Okay, that is equal 1 plus 3, root over 1 plus 3, that is root over 4, that is 2. And mod B vector is here, coefficient of x cap is minus 1 and coefficient of y is 0. So root over minus 1 square plus 0 square, that is equal 1, right? So if we put here, okay, and again we need to calculate A vector dot B vector, right? So A vector dot B vector, that is equal x cap plus root 3 y cap dot x cap, sorry, it is minus x cap, minus x cap. Okay, so x cap dot x cap is 1 and x cap dot y cap is 0. Okay, different, if we take the dot product of different unit vectors, then it will give us 0. So x cap times, so it becomes x cap dot minus x cap, that is minus 1. Okay, minus 1. So a vector dot b vector gives us minus 1. So we can write it as it implies minus 1 equal mod of a vector is 2 times mod of b vector is 1 times cos 2 theta. Okay, that implies cos 2 theta is equal minus half. Okay, and we know minus half means cos 120 degree. Okay, that means we can write 2 theta equal 120 degree, or we can write theta equal half of 120 degree, that is 60 degree. This is our answer, option B, 60 degrees. I hope it was clear to you. I tried to explain it totally for you. If you have any doubt, you can tell me in the comment section. Okay, so let's go to the next question. So this is our next question for today. Standing waves are excited in a 1 meter long pipe open at one end, closed at the other. Take the speed of wave as 340 meter per second and calculate the frequency of the first overtone, that is the first harmonic above the fundamental frequency. Option A 128 Hz, option B 170 Hz, option C 255 Hz, option D 510 Hz. And you can see that option C is the correct answer. Okay, so let's solve this question, and this question is from superposition of waves, that is vibration of air columns. From that part this question came. So let's solve this question. So first of all, the question says that standing waves are excited in a 1 meter long pipe which is open at one end and closed at the other. Now, I hope you remember that vibration of air columns in pipe are of two types. That is that pipe can be of two types. One is open pipe and another is closed pipe. Now, which one is open pipe? If the pipe is closed, if the pipe is open at one end, then it is called closed pipe. Okay, and if the pipe is open at both the ends, then it is called an open pipe. Okay, so I hope you could understand the difference between closed pipe and open pipe. So which pipe is this? This is a closed pipe, okay, which is open at one end and closed at the other. Okay, so what is the fundamental tone or fundamental vibration, fundamental tone created in it? So if I draw it, then this will be okay. This will be the fundamental tone, right? And the first harmonic above the fundamental is above the fundamental, the first harmonic is like is something like this, right? So this is the fundamental and this is the first harmonic over fundamental, right? So it is called also first overtone, okay? It is also called first overtone, okay? So this is the first overtone. Now we need to calculate the frequency of the first overtone. Okay, now how to calculate that? So the formula for frequency of the fundamental tone is N0 equal V by 4L. You may remember it or may not. But here is a process how you can remember. See, so this is the pipe, okay. Before that, I would like to draw one sine wave. This is the sine wave, right? This is the sine wave. So this is a complete wave or complete oscillation or complete wavelength, right? This is the complete wave. So this is the wavelength, right? So if there is a pipe here like this, like this, okay, this is the pipe, okay, and here is the portion of this sine wave, that is this portion, okay, suppose this portion. So if I repeat this along this side, that is the other wave, another wave, then this is the thing. So you can see here that this part is actually this one, that is 1/4, 1 part, 2 part, 3 part, 4 part, right? So 1/4 of the total wave, right? So if this is lambda, that is the wavelength of the wave, then this part is lambda by 4, right? Lambda by 4. So here if the length of the pipe is L, if the length of the pipe is L, then L is equal to lambda by 4, right? That is this thing is lambda by 4, right? This is lambda by 4 and that is equal to L. So L is equal to lambda by 4 and from there we can get frequency. Okay, now we know velocity V is equal to n times lambda, that is if V is the velocity of the wave, n is the frequency and lambda is the wavelength, then we can write n equal v by lambda, right? And from this we can write lambda equal 4L. So here we can get n equal v by 4L. So this is the fundamental frequency N0. Okay, this is the fundamental frequency N0. I hope you could understand how we get this formula of fundamental frequency. If you can't remember it, then you can find it in your exam also, but it's better to remember the formula for fundamental frequency. It's very easy. That is N0 equal V by 4L, right? So what will be the frequency of first overtone? Now for the frequency of first overtone will be 3 times of the fundamental tone. Why? See here, this thing actually, the 3/4 part of the, this is the 3/4 part of the total wavelength, right? See here, if I draw this full, then this is the total wave, full wave, complete wave, right? This is the complete wave, which is lambda. If this total is lambda, then this is 3 lambda by 4. Okay, so here you can write that L is equal 3 lambda by 4. Okay, and if you put if you calculate, sorry, it is 3 lambda. This is 3 lambda by 4. So from here we can get lambda equal 4L by 3. Lambda equal 4L by 3. So we can put this lambda in this equation. Okay, so it gives us N equal V by 4L by 3, that is 3V by 4L. So this is the first overtone N1. This is the formula for first overtone N1. So N1 equal 3V by 4L. N1 equal 3V by 4L. Okay, so this is the formula for frequency of first overtone. Now if we put the values of V and L here in this equation, we can easily calculate the frequency of first overtone here. So let's do it. So N1 equal 3V by 4L. So 3V here is you can see 340 meter per second. So 340 meter per second divided by 4L. L here is the length of the pipe, that is 1 meter. 1. Okay. So this is equal to 3 into 340 by 4. If you do it in your calculator or do the calculation, then it is equal to 255 Hz. Okay. I hope this is clear to you. So our answer is same as the answer given, correct answer given, that is option C, 255 Hz. I hope this is clear to you. If you have any doubt regarding this solution, you can tell me in the comment section. There are also there are more videos, previously solved videos, so you can watch them. You can find the links in the I button. If you like this video, then please click on the like button, share this video with your friends, and if you are a new viewer today, then don't forget to subscribe our channel. Ta-da!